Hello students, welcome back to the lecture series on Introduction to Scilab Software. This is video part 6 and we are going to solve the question set number 5. Now the first question is, declare the following polynomials with given roots. Now in the previous session we have seen that using the poly command we have declared the polynomials with given coefficients. Now how to define or how to declare a polynomial with given roots. Here roots are given and we have to declare the polynomial. So let us first of all see. We can give any name to the polynomial. For example, we can give P or Q1 is equal to, the first polynomial is poly, in the bracket, square bracket we have, the roots are I minus I, 1 minus 1. So we can write percent I in place of I minus percent I 1 comma minus 1. Since we are using the variable x, we are going to write x here. Now this is done. We don't need to write that c in the codes as we have seen in the previous. That c we were writing because we wanted the coefficient and we were giving the coefficient, and therefore this is x raised to 4 minus 1 is having 4 roots which are I minus I, 1 minus 1 respectively. You can see that. Now we want to evaluate the polynomial at 2. So for evaluating the polynomial at 2, we are going to write Horner, and in the bracket we are going to write Q1, the name of the polynomial, comma 2. If you want to evaluate Q1 at 2, we are going to write like this. So we get answer as 15. So two things we are learning here, that how we are defining the polynomial using given roots and the evaluating polynomials at the given number. Now the Q2, the roots given are 3 minus 2, 1. So let us write 3 minus 2 and 1. And this polynomial is x cube minus 2x square minus 5x plus 6. Now let us evaluate this polynomial Q2 at minus 4.5. We can evaluate it at 2 as well. Let us take the another number, minus 4.5. So this is the answer. Let me clear the console for the next. Now we want a polynomial using the poly command with given roots. Let us take it as 3 and the roots are square root 2, square root 2. So we can write, what we can write to find the square root, sqrt in the bracket 2 comma sqrt in the bracket 2. So we get the polynomial as this of degree 2. Now let us find, or let us evaluate the polynomial Q3 at 1 by 3, suppose the third number which is given, which is 1 by 3. This is the answer. Now try for the fourth one and call it Q4. The coefficients are 4. Sorry, the roots are 4. That means we have a polynomial of degree 4. 3, 4, minus 5, 1. So this is the degree 4 polynomial. Let us evaluate this polynomial, which is Q4 at 23 is given. So let us say 23. So this is the answer. Now in the second question, we want to find LCM and GCD. LCM is the least common multiple and GCD is the greatest common divisor of polynomials. We know how to find the LCM and GCD of numbers. Here we have the polynomials and this P2, P3 and P4 polynomials we have previously defined in the previous session in the question set 4. So you can refer to the question set 4. We are not going to define it again, or we can use the arrow key. We have the P2, this, we want P3 now, so we can use the arrow key, and we want the P4 as well. So this is our P4, and let us find LCM and GCD. So for LCM, the first question is about the GCD. Let us write GCD into bracket. You're going to write the square bracket and the two polynomials which you want, P2 comma P4. So the GCD is a common factor which is x minus 1. Next you want to find GCD of P3 and P4, and it is also x minus 1. The next we want to find the LCM. The LCM of P2 and P4. So the command is LCM in the round bracket, then we have the square bracket. The LCM is degree 4 polynomial. Same way, LCM of P2 and P3. Other way around also you can do P3 first and P2 afterwards. There is no difference. LCM. So let us evaluate this. So this is a degree 3 polynomial. So this way we have covered what we can do in the polynomials, like finding the LCM, GCD, finding the roots, factors, as well as evaluating polynomials at the given numbers. Thank you so much. We will continue in the next lecture.